Hey guys, so today we're going to do a video about how to solve derivatives using implicit differentiation. And before we get into how to solve them, I just want to explain what is implicit differentiation and when do I need to use it. So what we've worked with so far, what you guys have probably been working with, is explicit. And what this is the function in y equals f of x. So each one has y set equal to some function of x, and examples right here, y equals sine x, y equals 2x squared plus 5x. You're used to seeing ones like this. But then we get into implicit, and that's where we have x and y on one side, and we just can't really get y by itself. And so an example would be x squared plus y squared equals 10, x squared times y squared equals 25x plus y. That's another one. And these we have to solve the derivative pretty similar to normal. There's just one trick. And now let's look at the steps. We differentiate both sides with respect to x, but when taking the derivative of a y term, multiply by dy dx. And the second step is solve for dy dx. So let's look at this first step in a little more detail. Differentiate both sides with respect to x. That's what we do every time we take a derivative. So that sounds easy enough. And then it says, but when taking the derivative of a y term, multiply by dy dx. Let me just give a quick example of something like that would do this. Let's say we're taking the derivative, so d dx, because that's the derivative with respect to x. Let's say we've got 10y to the fifth. Okay, so what that equals? Well, differentiate both sides with respect to x. Let's just take the derivative like normal. We're going to get 50y to the fourth. And then it says, when taking the derivative of a y term, multiply by dy dx. So then, all we do here, just multiply by dy dx. And that's all we would need. That's implicitly, we just took the derivative of 10y to the fifth. Okay, so now when we get into more examples, we'll see how this actually works. Alright, so first example, x squared plus y squared equals 9. We got to differentiate both sides with respect to x. So we're taking d dx of x squared plus y squared equals 9, and we're also taking the derivative of that side. Okay, so derivative of x squared, that's easy enough, that's just 2x. Plus, we're going to take the derivative of y like normal, so we're going to get 2y, then multiply, because we took the derivative with the y, multiply by dy dx. Set that equal to, well, what's the derivative of 9? That's 0. Okay, so we just did step 1. Then the second step says to solve for dy dx. Well, that's just a little bit of algebra. We can subtract 2 here. We'll get 2y dy dx equals negative 2x, subtracted it to the other side. And now I can just divide by my 2y. And I'll be left with dy dx is equal to negative x over y, because the coefficients will just be simplified. And that's the derivative. That's it. So notice the answer is pretty unique from what you're used to seeing. Usually you get numbers and you get x values, but now we have a negative x and then a y in the derivative. Don't be too freaked out by this. This is normal, and that's what implicit differentiation is going to lead you to more often than not. So now number 2 is a bit harder of an example, and now you have to apply the rules that you've done in the past, like the product rule, and apply it to this implicit differentiation. So let's start here with 2x squared times y to the fifth. That's going to require the product rule. So I'm going to take the derivative of the first term and leave the second one alone. Derivative of 2x squared is 4x. Multiply it by second one, just leaving it by itself, so y to the fifth. Then I'm going to add it, and then now the product rule says to take the derivative of the second function, which would be 5y to the fourth. Remember, this is implicit differentiation. We took the derivative with respect to y, got to multiply by dy dx. And then, finishing the product rule, we leave the first function alone, so 2x squared. Alright, plus derivative of 3x is just 3, equals derivative of 10y is going to be 10, but again, we took the derivative with respect to y, so dy dx. Derivative of 5 is 0, don't need to put anything there. So this is what we're left with. Now I'm just going to get rid of my parentheses. I always put them in for some reason. They don't really serve a purpose. So plus 5y to the fourth, 2x squared, and then I'm going to just tack the dy dx on the end. I'm going to bring this 10 dy dx over because you'll get used to, you're eventually going to have to get used to sending the dy dx is always on the same side. Because in the end, we're going to have to factor out a dy dx to be able to solve for it. So to factor out a dy dx, eventually we need to get rid of everything that doesn't have a dy dx on it. Well, that is this term, 4xy squared, or to the fifth. So that's going to go to the other side. So I'll be left with 5y to the fourth times 2x squared times my dy dx. I'll do minus 10 dy dx, and I'll bring the 3 over as well. So I'll get minus 4xy to the fifth minus 3, and now is when I can factor out a dy dx. See how both these terms have a dy dx on the end? So let's factor that out. So dy dx equals 5y to the fourth times 2x squared minus 10. That equals the negative 4xy to the fifth minus 3. Now I can just divide out, and that'll leave me with dy dx alone, and that's what I wanted. So I'm going to divide 5y to the fourth, 2x squared, minus 10 from both sides. So 5y to the fourth, 2x squared, minus 10. And I'll get dy dx, finally got an answer here, equals negative 4xy to the fifth minus 3 divided by, let me simplify this term a little bit, I can multiply my constants. I'll get 10 x to the second, y to the fourth, I think, yep, minus 10. And that would be my derivative. That is dy dx. And you're going to see a lot like this where we have to bring everything to the same side until we can factor out a dy dx, and then we're just going to have to divide whatever is attached to dy dx, and that'll give us our answer. You'll see a lot of those as you do more and more implicit differentiation. I hope this was just an introductory video. I hope this made sense. I'll have a lot more videos with examples of this. So let me know if you have any questions. Thanks for watching, guys.